This is an example of Module 10 chemistry, temperature, depression, freezing point temperature depression problem. So the problem states when 15.0 grams of sodium chloride are added to 100.0 grams of water, what is the change in the water's freezing point? And they give you the constant, Kf of water is 1.86 degrees Celsius per molality. And so the first thing you should recognize in reading this problem is that they want to know the water's freezing point change. Okay, and so we know an equation that relates the change in the freezing point of a solvent and its relationship to the number of molecules or ions that the solute forms in solution, the constant for that solvent, and the molality of the concentration of the solute. And so we know that this is the equation we want to use, where delta T, the change in the freezing point of the water solution, is related to I, the number of molecules or ions that the solute forms in solution, the constant for the solvent, and the molality of the solute or the solution. So when we look at a word problem like this, or we want to know, what do we know? What does the problem tell us? So in reading the problem, we know that we have 15.0 grams of sodium chloride. Remember, when we're looking at grams, this is a measure of the mass. So we know the mass of sodium chloride for this problem. And we know that that 15.0 gram sample of sodium chloride is added to 100.0 grams of water. Right? So it's not a volume, but we know the mass of the water in grams. So those two things we know, and of course we also know the constant for water. And what we want to know is delta T. What is that change in the water's freezing point? Okay, so anytime you do these problems, you want to know what equation relates the things that we know to the things that we don't know. And then we look at this equation, what things can we figure out? All right, so again, restating, I is the number of molecules or ions that the solute, in this case it's going to be sodium chloride, how many molecules or ions will that form when it's dissolved in this 100.0 grams of water? All right, we know the constant. And molality, what do we know about molality? Molality is a measurement of concentration, and it relates the number of moles of solute per kilogram of solvent. All right, so this makes us kind of question now, right? Do I know the number of moles of the solute, which is sodium chloride? Well, if I go back to look at what we know, no, I don't know the moles of solute that I have. I know the mass. And do I know the mass of the solvent in kilograms? Well, I know the mass of water, the solvent, but it's in grams, so I know at some point I'm going to have to convert that to kilograms. But first, let's start with moles. I know the mass of sodium chloride, and this builds on something we've been doing almost all year now, right? So moles is the number of molecules of a substance. All right, and we know that there is a relationship between the mass of sodium chloride in AMU of one molecule. If that is converted to grams, if we measure that out in grams, that will tell us how many grams contains 1 mole of that substance, and that's something that we call the molar mass. All right, so in order to convert our 15.0 grams of sodium chloride to moles of sodium chloride, we have to determine the molar mass of the sodium chloride. And how do we do that? Right? We go back and we know that we have 1 atom of sodium and 1 chlorine atom. And if we look at the periodic chart, the atomic mass for sodium is 23.0 AMU, and the atomic mass for chlorine for one chlorine atom is 35.5 AMU. And when we add that together, it's 58.5 AMU for one molecule of sodium chloride. Now, if we remember, AMU is not equal to grams, but if I take this number and I go into the lab and I pull off of the shelf a bottle of sodium chloride and I weigh out 58.5 grams of sodium chloride, I know that in that 58.5 grams of sodium chloride, I have exactly 1 mole of sodium chloride. Now here is a relationship that we can use, right? If in my original sample, I only have 15 grams of sodium chloride, that's not anywhere near 58.5 grams of sodium chloride. So I know I'm going to have less molecules of sodium chloride. I'm going to have less than 1 mole of sodium chloride. So I take that 15.0 grams of sodium chloride, and I know I'm going to divide by 58.5 grams of sodium chloride because I want the grams to cancel, leaving me with the number of moles that I have. When I do this mathematical expression, 15.0 grams divided by 58.5 grams of sodium chloride, I end up with a number that looks like this, 0.25641. Okay, and it's going to be moles of sodium chloride, but I have to look back here at my equation, and in both of these numbers I only have 3 significant figures, so I only want 3 significant figures in my answer. And so I know that I want the 2, the 5, and the 6, but I need to know what to do with this 6, so I look to this 4th number. Since it is less than 5, I'm going to leave that number as a 6. If that 4 was a 5, I would raise that 6 to a 7. So now I know that in my 15.0 gram sample of sodium chloride that I have in this problem, in that sample I have 0.256 moles of sodium chloride. So I'm getting closer to determining the molality, the concentration of my salt solution, and that's what I need in order to use this change in temperature equation. I have to know molality, and right now I still don't. I now have the moles part of this equation, but now I need to know what is the mass of my solvent, which is water, in kilograms. Well, I know that I have 100.0 grams of water. What relationship do we know that relates grams and kilograms? So I know that for every 1 kilogram of substance, I have 1,000 grams of that substance. So this becomes my conversion factor. I start out with 100.0 grams of water, and I'm going to divide by 1,000 because I know that I want my grams to cancel, leaving my kilograms. So 100 divided by 1,000 equals 0.1000 kilograms of water. And the reason I write this number like this is because there are 4 significant figures here. This first 0 in my answer is not significant. So here's 1, 2, 3, 4. So I need to write this number exactly this way. So then I can look now at my equation for molality. I now know the moles of my sodium chloride, which is my solute. I know now the mass of my solvent, water, in kilograms. So now I can use this equation to determine the molality, the concentration of my salt solution. And I simply plug in 0.256 moles of sodium chloride and divide that by 0.100 kilograms of water, and it results in an answer of 2.56 molality solution of sodium chloride. And the reason I have 3 significant figures is because of this number right here. So now I know, going back to our temperature depression equation, and remember the change in temperature is what we want to know. I know my Kf, that's my constant. Now I know my molality is 2.56 molality of sodium chloride. That's this number here. How do we determine the I value? Well, when I dissolve sodium and chloride in water, remember that it splits into 2 ions, sodium and chloride. And so my I value will be 2 because there are 2 substances, 2 ions that need to be surrounded by a water molecule. And so now I simply plug in those numbers. And remember the negative, right? So I have 2 ions. My constant is 1.86 degrees Celsius per molality, and my molality is 2.56. Okay, molalities will cancel. There is no unit on the 2, and the answer will be in degrees Celsius, which if you're measuring temperature, that's what you want. And when I do this multiplication problem, I come up with an answer of negative 9.5232 degrees Celsius. But I have to look back at my equation. I can ignore the 2 and the 1.86 because those are, or actually I can ignore the 2 because that's an exact number. And so I have 3 significant figures here, so I know I need to round this number to this 2, and I look at the 3, so that 2 stays a 2. So my change in temperature is negative 9.52 degrees Celsius. That's the change in the temperature. Now, if they wanted to know what is the resulting or the new freezing point temperature, we would have to subtract this number from 100, and of course in this case it would, or from 0, and in that case it's still negative 9.52 degrees Celsius. That's not always the case though. Alright, and that, so negative 9.52 degrees Celsius is how much that freezing point will change when you add 15.0 grams of sodium chloride to 100.0 grams of water.